Hey guys, welcome to part 2. We'll try to make this go quickly so we can finish up this section 1.2. So we were looking at our acronym, GEM-DOS, grouping symbols, exponents, multiplication and division from left to right, and addition and subtraction from left to right. And we identified that we needed to simplify some grouping symbols here. So again, we put brackets or little whatever you want to call that underneath. So I know this is what I'm simplifying. Everything else comes down. So everything else that doesn't have a little bracket around it, I will bring down as it is. So negative 2 squared plus, and then the 1 minus 3 simplifies to negative 2. That fourth exponent comes down, and then negative 2 comes down, and 4 minus 3 simplifies to 1. Okay, so there's nothing inside the parentheses that I need to simplify. However, we're going to move on. Now I'm going to look at exponents. Now I have two exponents here. And there's a really big difference between these two numbers. The first number does not have parentheses around it between the base and the exponent. The second digit over here does have parentheses around the base, between the base and the exponent, and that's really important. When a negative number is not in parentheses, just like this, then we don't actually include that negative as part of the base. Our base is just 2, so that's what we're squaring. My negative sign is going to come down. So again, I'm going to put brackets around what I'm working with, and everything else comes down. Because I'm not including that negative sign, it comes down. And then we're left with 2 squared, which is 4. So I now have negative 4. Here I have negative 2 to the 4th power. So remember, that's negative 2 times itself 4 times. Negative 2 times negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is 4. Negative 2 times negative 2 is 4. And 4 times 4 is 16. See how that changed the sign and became positive? Or over here it stayed negative? That's because of those parentheses. So be very careful that you recognize the difference between those two things when you're working independently. All right, and now I'm going to go to I have no more exponents, so now I'm going to do multiplication and division from left to right. So moving left to right, I don't see an X or a dot, but I do know that a number next to another number with parentheses in between, in algebra, the implied operation is multiplication. So I do need to multiply that. So brackets, because that's what I'm working with, and everything else comes down. Negative 4 plus 16 minus 2, because minus 2 times 1, 2 times 1 is 2. Finally, I'm going to do addition and subtraction from left to right, and I'm actually going to do another little step that they're not going to do here. So I'm going to do my first one, negative 4 plus 16. Remember, when my addends have opposite signs, I subtract the smaller digit from the larger, so 16 minus 4 is 12, and then my answer gets the sign of the larger. So because 16 is larger, it's positive, my 12 is going to be positive. If you want to just flip that around, that's the same as 16 minus 4. And then my minus and my 2 come down. And now I'm going to do this again because I'm still adding, subtracting from left to right. 12 minus 2, which simplifies to 10. All right, we have another example here. So let's look at this again. GEMDAS, GEM-DOS. We're going to start with grouping symbols, and I do have absolute value bars this time as my grouping symbol. A bracket around what I'm simplifying. My 3 and my minus come down, so I have 3 minus, and inside my grouping symbol, 2 minus 8, I have negative 6. Remember, when my addends have negative signs, so I have a positive 2 and a negative 8. We take the smaller from the larger, so 8 minus 2 is 6, and my difference gets the sum of the larger. 8 is a larger digit or has absolute value that's larger, so my answer is negative. If you're thinking of this on a number line, I'm starting at 2, and I'm moving to the left 8. So obviously my answer is going to be a negative number because 0 is right here. All right, I've done my grouping symbols. I don't have any exponents, so let's see if there's any multiplication or division. 3 minus, oh, I'm not quite done yet. Let's go back to grouping symbols. This says the absolute value of negative 6. I can simplify that. So let's come back down. My 3 and my minus come down. The absolute value of 6 is how far away it is from 0, and negative 6 is 6 spots from 0. So I have 3 minus, and then the absolute value of negative 6 is 6. Now we can go to multiplication and division, and I don't have any. Moving from left to right, addition and subtraction, I do. Okay, there are a couple of different ways you may want to think about this. Starting at 3 and moving to the left 6, if you're thinking of a number line in your head. Or if we're using the steps for the add-ins, we have two add-ins with different signs. We have a positive 3 and a negative 6. When that's the case, subtract the smaller digit or the smaller absolute value from the larger digit. So 6 minus 3 is 3. And then your difference gets the sign of the number or the digit with the larger absolute value. 6, negative 6 has a larger absolute value than positive 3. 6, 3. It gets the sign of the larger digit. So it's going to be, since that says minus 6 or negative 6, my difference will be negative 3. All right, let's turn our attention to algebraic expressions, which involve plugging and chugging. And this is a definition, so write it in the vocab section. An algebraic expression is a constant, that means a number, a variable, or a combination of these symbols and operation signs that is used to represent a number. So no equal sign in an algebraic expression. It could be just a number, it could be a variable, it could be some combination of these things, like 3 plus x. Okay, it's used to represent a number. There is no equal sign. Okay, no equal sign in an expression, so make sure you note that. We can use the substitution property to plug in values for our variables and do what my math teachers always called plug and chug. Okay, here's our official definition. If A equals B, then A can replace B in any expression to produce an equivalent expression. So basically, if A equals 4, then every time I see 4 or A in my expression, I can plug in 4 or substitute 4 or whatever number that may be. So to evaluate an algebraic expression containing variables, we substitute the value for each variable into the equation and simplify. Or, like I just said, my math teachers always said, plug and chug. We plug in the values and we chug out the computation. Let's try one. We know that x is equal to 2, y is equal to negative 3, and z is equal to 1/4, which means every time we see x, we can substitute 2. Every time we see y, we can substitute negative 3. And every time we see z, we can substitute 1/4. So here's our initial expression, not equation, no equal signs here. And we're going to substitute in. Now every time I substitute, I'm going to use parentheses, because I want to make sure that I'm not replacing the exponent, I'm not replacing the addition or the subtraction sign, I'm only replacing the letter itself. So let's go ahead and substitute in. For the x, we have a 2 squared. For the y, we substituted in negative 3. Notice we didn't change our sign here. We're not substituting for the addition and subtraction sign. We're only substituting for the letter. So use those parentheses. And then instead of z, we have 1/4. We'll now use our order of operations to simplify this. We do need to start with our exponent here. So 2 squared is 4. And then plus negative 3 is just the same as minus 3. And then minus positive 1/4, which is the same as minus 1/4. Well, now we don't have any multiplication and division, so we can just add and subtract from left to right. 4 minus 3 is 1, so we're left with 1 minus 1/4. And if you don't know how to do that mentally, remember 1 is just the same thing as 4/4. 4/4 minus 1/4 equals 3/4. If you need some help with fractions, make sure you let me know. Let's try a second one here. X squared minus y squared over xz. Again, we're only substituting for the x and the y. We don't want to mess with the exponents. We don't want to mess with that subtraction sign. So let's use parentheses to substitute. So we've got 2 squared minus, substitute in for our y, negative 3 squared over x times z, or 2 times 1/4. We should have parentheses here. Using our rules of exponents, our rules of order of operations, let's simplify. We don't have anything inside the grouping symbols we can simplify, so let's go to exponents here. We have 2 squared and negative 3 squared. We'll rewrite that as 4 minus 9. The minus comes from here, and the negative 3 squared is just 9. On the bottom, 2 times 1/4 is 1/2. If you've forgotten how to multiply fractions, 2 is just the same as 2 over 1. 2 is Not only is it a natural number, it's also a whole number, an integer, and a rational number. We can write it as a fraction. 2 times 1/4, we multiply across the top. 2 times 1 is 2, and we multiply across the bottom. 1 times 4 is 4. 2 over 4, which is the same thing as 1/2. That's where that 1/2 came from. So we have 4 minus 9 over 1/2. I'll simplify again. So I have 5 over 1/2, which is 5 divided by 1/2. Using the inverse, multiplicative inverse, that's the same thing as, it should be negative 5 times 2, which is what we have written here. Okay, this is relying on your knowledge of fractions. If you need some help with fractions, again, be sure to let me know. And negative 5 times 2, two groups of negative 5 essentially would give me negative 10. All right, let's try one more here. For our last example for today, example C, 2x squared plus 3y, all being raised to the third power. Again, I'm going to put parentheses just around what I'm substituting. I'm going to keep those parentheses there. I don't want to substitute or drop or miss anything else. So everything else comes down, but instead of x in parentheses, I now have a 2. And instead of y in parentheses, I now have a negative 3. All right, inside my parentheses grouping symbols, there's nothing to simplify, but I do have an exponent. Now all of this is inside bracket grouping symbols, so we're kind of doing double grouping symbols here. So using just this exponent, I have 2 times 4, and then I would have written 3 times negative 3, and then gone and done my multiplication, but you can see in the example here, they did that already. Hey, I now need to do multiplication from left to right, so I'm going to get 8 minus 9, all of that being raised to the third power. I still haven't simplified everything in my grouping symbols yet, so let's keep going. 8 minus 9, starting at 8 and moving left 9, I do get negative 1. Again, if you're thinking of the add-ins rule, they have different signs, so subtract the smaller digit from the larger, so 9 minus 8 is 1. And then you take the sign of the larger digit. Because the 9 was negative, and that's 9 is bigger than 8, we get the negative sign from the 9. All right, negative 1 cubed is negative 1 times negative 1 times negative 1. If you remember, negative 1 times negative 1, two negatives equal positive, so 1. We saw that other negative 1 here, though, and 1 times negative 1 is negative 1. All right, guys, I told you that was our last example, so we are going to stop right there. I know this is a little bit of a longer video, but I wanted to make sure that you guys had some good examples for how to do the order of operations and that you were reminded about how to add add-ins with the same sign or add-ins with different signs. I briefly touched on fractions, so if you're still feeling a little foggy on how to add, subtract, multiply, or divide fractions, be sure to check with me, and we'll throw some examples in and some work there in our Do Now or End class. Have a great evening, guys, and I'll see you next class.